Okay, Honors Algebra 2. Good morning, good afternoon, good evening, whichever it is. And welcome to Mr. Patterson's class. This is Mr. Clendenin. This should be Tuesday the 28th, if I've got that right. Yesterday, you looked at something called summation notation, that fancy Greek letter, sigma, which made you add up the terms that it generated. Okay, and you added them up and you came up with a sum. That's why it was called summation notation, and it's also called sigma notation. Well, today we're going to kind of narrow that down to what happens whenever what we're adding up is an arithmetic sequence. All right, so like this first example I have down here, we see that we are adding 6 all the way across the line here. So that makes it arithmetic. Remember, whenever you add or subtract, it's arithmetic. And if you add them up, it's called a series. So this is called sums of arithmetic series. Okay, and there's a way to do this, a quick way that'll save you a lot of time. That's what I'm going to show you. All right, so let's take this series that I have where we're starting at 5 and we're adding 6. Let's do two things. First thing let's do up here is let's find the sum of the first 4 terms. So those 4 numbers right there, 5 plus 11 plus 17 plus 23. Okay, and let's find the sum, and that's a 5. Let's find the sum of the first 4. That's what that would look like, S sub 4. Well, you can kind of do that in your head, since it's only 4 numbers, and just add 5 plus 11 is 16, plus 17 is what, 33, plus 23 is 56. And that one's not too hard to do in your head because it's a short list. Okay, but what if that was longer? So here we're going to add up 43 terms. We want to try to do that in our head or our calculator. We'll lose track. Is there a way to do this that is shorter and quicker and a lot easier? Yes, there is. And here is the formula that does it for you when it's an arithmetic sequence. S sub n equals n over 2. And now remember what n is. N is how many numbers you are adding. So the numbers you are adding, or how could we say that? The number of numbers you are adding. I'll just write that way. The number of numbers you are adding. So you're adding up 6 numbers, 20 numbers, 43 numbers. We're going to add up 43 of them. Okay. And all we need to know is a sub 1, which is our first number that we add, and a sub n, which would be the last number we're going to add. Okay. So with what we just did down here, what do we know whenever we're adding up 4 numbers as far as that formula goes? We know how many numbers we're adding up, 4. We see the first number is 5 in our list that we're going to add, and we see the last number, or the 4th number, is 23. That's all we need to know to add up this list. And what we would do is we would say, okay, what's the sum of the first 4 numbers? Well, I'm adding up 4 numbers. I divide that by 2. What's the first number I add? 5. What's the last number I add? 23. That's all we need to know. The first number, the last number, and how many numbers we add. So let's simplify this. We would get 4 divided by 2 is 2, 5 plus 23 is 28, 2 times 28 is 56. So we get the same answer there. Okay. Now what's the benefit of this formula? I didn't have to know any of these numbers in between, so I didn't have to know the 11 and the 17. Okay. So now let's look then, how would we add up the first 43 numbers in this list? And if you may want to pause it here if you need to catch up with your notes, I'm going to clear all this off. Okay. So we want to add up all 43. Now again, we already looked at this. We're adding 6 all the way across, so we know it's arithmetic. It has to be arithmetic in order to use this formula. Okay. Somewhere out here, eventually we will add on the 43rd number. So we want to know, let's just run through our formula. We want to know the sum of the first 43 numbers. So the first thing we need to know is how many numbers are we going to add together? Well, that's 43. So it'd be 43 divided by 2. Then we need to know the first number we're going to add. We see it, it's 5. And then we need to know the last number we're going to add. Well, that's the 43rd number. We don't know what the 43rd number is out here. They didn't tell us. And we definitely don't want to do plus 6, plus 6, plus 6 all the way out there to figure out what it is. So what can we do? We can use our formula from, what would it have been, 2 weeks ago. Remember how that formula worked. How do you get to any number in a arithmetic sequence. You start at the first number and you add n minus 1 of your d's. Remember that? So what would that tell us here for the 43rd number? We would start at 5 and we would add 42 sixes. And punch that in my calculator, I find out the 43rd number is 257. So now we have all we need to know. We have the first number in our list, we have the last number that we're going to add, and we know how many numbers we're going to add, 43. So now it's just a matter of punching it in our calculator. It'll be 43 over 2 times 262. And if you wanted to, you could even reduce that 2 and that 262 to 131. Anyway, you end up with a sum of, so the sum of the first 43 numbers in this list is 5,633. And that's something we definitely would not want to try by hand, so we need to make use of this formula. Okay? All right, if we are in summation notation like you saw yesterday, so here we have the sum from 1 to 50 of 3i plus 2. So that means, again, we want to add up, we want to plug in 1, plug in a 2, plug in a 3, go all the way up to plugging in 50 and add all those numbers up. All right, well, how many numbers would we actually be adding up? Well, whenever you start at 1 and you go to 50, that's going to generate 50 numbers. All right, now the mathematical way to figure out how many numbers you're going to add up is you take your upper bound minus your lower bound and then you add 1. So we would do 50 minus 1 plus 1. So that's the mathematical way to figure out that you're adding 50 numbers together. But if you start at 1, then whatever that upper bound is, that's going to tell you how many numbers you're adding up. All right? Now, I don't know, Mr. Patterson didn't talk about this yesterday, but whenever your rule is a linear rule, what do I mean by linear rule? It takes on the form y equals mx plus b. mx, like 3i plus b plus 2. 3i plus 2, mx plus b. That's linear. Whenever it is linear, it will be arithmetic. Okay? Now, just to show you, we're going to plug in, I'll plug in a few numbers here and we'll see what happens. When we plug in 1, we get 3 plus 2, we get 5. When we plug in 2, we get 6 plus 2 is 8. When we plug in 3, we get 9 plus 2 is 11. When we plug in 4, we get 12 plus 2 is 14. And we can see here what we're doing. We're adding 3 as we go across the line. So it is arithmetic. Now, why is that important? That means we can use this formula to figure out what we would get when we add them all up. Okay? Now, all we need to know in this formula is n. How many numbers we're adding up? Well, we know we're adding up 50 numbers. So that'll be 50 over 2. Then all we need to know is the first number we would add. Well, we just figured that out right here. It was 5. And then we need to know the last number we had. Well, if we're adding 50 numbers, then that's a sub 50. Well, how do we get a sub 50? We take our upper bound 50 and we plug it in. So what would happen when we plugged in a 50? We would get 3 times 50 plus 2. 150 plus 2. We find out that our last number we would add would be 152. And then we can just do the math and say, well, that's going to be 25 plus 100, or times 157. And we find out when we add up these 50 numbers, it's simply 25 times 157. Yeah, 25 times 157. Let me grab a calculator. 3,925. Thought I already had that one done, and I didn't. Okay, so there you go. Easy way to add up these when they're arithmetic. Now, one thing about today is, just remember this, when it's linear, this rule is linear, that automatically means it's arithmetic. And again, why is that good? Because that allows us to use this formula. And in this formula, all you need to know is how many numbers you're adding, what the first number you're going to add, and what the last number you're going to add is. And you can figure out what the grand total would be without having to know every single number in that list, which is good. Okay? All right. So for your homework, here's 2 problems for your homework. One kind of each like we did in the examples and notes. Post your pictures. And I guess that's all I got for you. We'll see you tomorrow. Bye.